Welcome to Real Civil YouTube channel. In this video, I am going to explain you how to interpret the results of shear reinforcement in ETABS software. So if you design the beams in ETAB, and if you go to concrete frame design and display design info, and here if you select the shear reinforcement and click on apply and OK, these results will be there. Okay, so we will select randomly. So this is one slab and this is the beam. At the left portion 737.71 is the value. So this value does not represent the area, it also not represent the spacing, but actually it represents the ratio of area and spacing. Okay, so how to calculate the spacing from this value I am going to tell you in this video. Okay, so for this we have to open the IS 456 2000. So in that the formula is given VUS is equal to 0.87 FY ASVD upon SV. Okay, so if you see here, so VUS is nothing but the shear coming on the beam. Fy is your grade of steel. ASV is the area of shear reinforcement. D is the depth of the beam, and SV is the spacing. Okay. So suppose this is our beam, and in that beam, this is the shear reinforcement. Okay. So we will assume that this is 8 mm two-legged stirrup. Okay. So why two-legged? If I cut this section, so here I can see one area of 8 mm bar, and here I can see one area of 8 mm diameter bar. Okay, so that's why it is two-legged. Okay, so let's interpret the results of ETAB. So as I told you, this 737.71, this value is, here you can see 737.71. Okay, so this value actually represent the ratio of ASV upon SV from this formula, that is ASV upon SV. Okay, so suppose we want two-legged stirrup of 8 mm diameter, then this will be the area. How to calculate area? As it is two-legged, it is 2, then pi by 4 d square, that is pi by 4 into 8 square is the area. So our final area is 100.48 mm square. Okay, so here we will put this value. We will take this on right side and divide and take this on the left side. So spacing will be equal to ASV upon 737.71. So my area is 100.48 divided by 737.71. Here I will multiply by 1000 so that my result will be in millimeter. So if you solve this, our spacing will be 136.20 mm. So that is the spacing at the end of the beam, that is at this portion. So this is how you can calculate the spacing for the shear reinforcement from this value. Similarly, you try for 699.62. You put this value, you assume some area, you assume two-legged, four-legged stirrup, and then check what is the spacing of the reinforcement. So that is the actual meaning of that value. So it is not the area, not the spacing, it is the ratio. If you have any doubt related to this, you can ask me, you can comment me, I will surely reply. Please like, share, subscribe the channel. Thank you so much.